When sizing electrical feeders for a large chiller, a crucial consideration is determining whether to base the calculations on the minimum circuit ampacity, or MCA, or the maximum overcurrent protection, or MOCP. The answer in this scenario is to size the feeders to the MOCP. Understanding the distinction between these two values is paramount for ensuring both safety and compliance with electrical codes. The minimum circuit ampacity represents the minimum permissible ampacity for the conductors that supply the chiller. This value is determined by the chiller manufacturer and is typically found on the equipment's nameplate. The MCA accounts for the continuous and non-continuous loads associated with the chiller's operation, including the compressor, fans, pumps, and control circuits. It is essential to select conductors with an ampacity equal to or greater than the MCA to prevent overheating and potential fire hazard. The maximum overcurrent protection, on the other hand, specifies the maximum allowable rating for the overcurrent protective device, such as a circuit breaker or fuses, that protects the chiller circuit. The MOCP is also provided by the chiller manufacturer and is intended to safeguard the equipment from short circuits and ground faults. The MOCP rating must not be exceeded when selecting the overcurrent protective device. Now let's delve into why the feeders should be sized to the MOCP, not the MCA. The primary reason is to provide adequate protection against overloads and short circuits. The overcurrent protective device is designed to trip and interrupt the circuit if the current exceeds the MOCP rating, thereby preventing damage to the chiller and the electrical system. If the feeders were sized solely based on the MCA, they might not be capable of handling the higher currents that could occur during fault conditions. This could result in the overcurrent protective device failing to trip, leading to potential equipment damage, fire hazards, and even electrical shock. Furthermore, sizing the feeders to the MOCP ensures compliance with the National Electrical Code, or NEC. The NEC provides specific guidelines for sizing conductors and overcurrent protective devices for various types of equipment, including chillers. These guidelines are intended to promote electrical safety and prevent hazards. To illustrate this concept, consider an example where a chiller has an MCA of 382 amps and a MOCP of 600 amps. If the feeders were sized solely based on the MCA of 382 amps, they would be protected by an overcurrent device rated at or below 382 amps. However, if a fault condition occurred that caused the current to exceed 382 amps but remain below 600 amps, the overcurrent device would not trip, and the feeders could potentially be damaged. By sizing the feeders to the MOCP of 600 amps, the overcurrent device would trip at 600 amps, protecting the feeders and the chiller from damage. It is important to note that the feeder conductors must be sized to carry the larger of the continuous load plus 125% of the non-continuous load, or the MOCP. In some cases, the MOCP may be lower than the calculated conductor ampacity based on the continuous and non-continuous loads. In such situations, the conductor ampacity must still be sufficient to carry the calculated load. When selecting the appropriate conductor size, factors such as the ambient temperature, the number of conductors in a raceway or cable, and the type of insulation must be taken into consideration. These factors can affect the ampacity of the conductors and must be accounted for to ensure that the conductors are properly sized. The NEC provides tables and guidelines for adjusting conductor ampacity based on these factors. For example, NEC Table 310.15b16 provides ampacity ratings for various types of conductors based on their size and insulation type. NEC Section 310.15b3 provides adjustment factors for the number of conductors in a raceway or cable. It is also essential to consider the voltage drop in the feeder conductors. Excessive voltage drop can cause the chiller to operate inefficiently and can even damage the equipment. The NEC recommends limiting voltage drop to 3% for feeders and 5% for the combined feeder and branch circuit. To minimize voltage drop, larger conductor sizes may be required. In addition to sizing the feeders correctly, it is also important to select the appropriate type of overcurrent protective device. Circuit breakers and fuses are the two most common types of overcurrent protective devices. Circuit breakers are resettable devices that can be tripped manually or automatically in response to an overcurrent condition. Fuses are non-resettable devices that must be replaced after they have blown. The selection of the appropriate overcurrent protective device depends on factors such as the interrupting rating, the time current characteristics, and the application. The interrupting rating of the overcurrent protective device must be sufficient to interrupt the maximum available fault current at the installation location. The time current characteristics of the overcurrent protective device determine how quickly it will trip in response to an overcurrent condition. The selection of the appropriate time current characteristics depends on the type of equipment being protected and the potential for nuisance tripping. In summary, when sizing feeders for a large chiller, it is crucial to size them to the MOCP to provide adequate protection against overloads and short circuits and ensure compliance with the NEC. The MOCP represents the maximum allowable rating for the overcurrent protective device that protects the chiller circuit. By sizing the feeders to the MOCP, the overcurrent protective device will trip and interrupt the circuit if the current exceeds the MOCP rating, preventing damage to the chiller and the electrical system. Furthermore, it is important to consider factors such as the ambient temperature, the number of conductors in a raceway or cable, the type of insulation, and the voltage drop when selecting the appropriate conductor size. Selecting the appropriate type of overcurrent protective device is also essential for ensuring proper protection of the chiller and the electrical system. Consulting with a qualified electrical engineer or contractor is recommended to ensure that the feeders are properly sized and protected. This will help to ensure the safety and reliability of the chiller and the electrical system. Always refer to the manufacturer's specifications and the latest edition of the NEC for specific requirements and guidelines. This information is intended for general educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or contractor before making any electrical installations or modifications. Proper feeder sizing based on the maximum overcurrent protection, or MOCP, ensures the electrical system's safety and the chiller's operational longevity. Neglecting this principle may lead to equipment damage or hazardous conditions. It is also a good practice to conduct regular inspections and maintenance of the electrical system to identify and address any potential problems before they escalate. This includes checking the condition of the conductors, the overcurrent protective devices, and the connections. Loose or corroded connections can cause overheating and can lead to equipment failure or fire hazards. Over time, conductors can become damaged due to exposure to heat, moisture, or physical stress. Damaged conductors can have reduced ampacity and can be more susceptible to overheating. Overcurrent protected devices can also degrade over time and may not trip properly in response to an overcurrent condition. Regular testing of overcurrent protective devices is recommended to ensure that they are functioning correctly. In addition to regular inspections and maintenance, it is also important to keep accurate records of the electrical system. This includes records of the conductor sizes, the overcurrent protective device ratings, and any modifications or repairs that have been made. These records can be helpful for troubleshooting problems and for ensuring that the electrical system is properly maintained. Finally, it is important to remember that electrical work can be dangerous. Always take appropriate safety precautions when working with electricity. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing circuits before working on them. If you are not qualified to perform electrical work, it is best to hire a qualified electrical engineer or contractor. Sizing electrical feeders for chillers is a critical task that requires careful consideration of various factors. By understanding the difference between the minimum circuit ampacity, or MCA, and the maximum overcurrent protection, or MOCP, and by following the guidelines provided in the NEC, you can ensure the safety and reliability of the electrical system and the chiller. Remember to always consult with a qualified electrical engineer or contractor before making any electrical installations or modifications. This will help to ensure that the work is done correctly and safely. Also, consider the environmental factors in Henrico County, Virginia, such as temperature fluctuations and humidity levels, when selecting conductors and equipment. These factors can affect the performance and lifespan of electrical components. In addition to the NEC, local codes and regulations may also apply. Be sure to check with the local authorities to ensure that all electrical installations comply with the applicable codes and regulations. Furthermore, it's important to consider future expansion when sizing feeders. If there is a possibility that the chiller's load will increase in the future, it is wise to size the feeders accordingly. This will avoid the need for costly and disruptive upgrades later on. Oversizing the feeders slightly can provide a margin of safety and can accommodate future growth. However, it is important to avoid oversizing the feeders excessively, as this can lead to increased costs and may not provide any additional benefit. Finding the right balance between current needs and future potential is key to optimal feeder sizing. To reiterate, always prioritize safety and compliance with electrical codes when working with electrical systems. Electrical work can be hazardous, and it is essential to take all necessary precautions to prevent accidents and injuries. If you are unsure about any aspect of electrical work, it is best to seek professional assistance. The minimum circuit ampacity, or MCA, and the maximum overcurrent protection, or MOCP, are critical parameters for chiller installations. Understanding their significance and applying them correctly is essential for ensuring the safe and reliable operation of the equipment.